Let's discuss Leetcode problem number 1826, faulty sensor. Before we discuss, please share, like, subscribe and hit the bell button for notifications. Also, I have added a lot of quizzes to the community page. Please check it out. Now back to the problem. This faulty sensor problem can be explained better with the examples. Say for example, there are two sensors which spit out data of numbers. One of them is faulty. The faulty one drops the data, and for the problem's sake, that data will be replaced with an extra number. So now your aim is to find out, your problem is to find out which one is the faulty sensor, sensor 1 or sensor 2. Now in this case, say for example, you assume sensor 2 is the right data, the good one. So you run through the good one and 2, 1, 3, 4 and see by dropping when they don't match the good one with the bad one. When they don't match, you drop the data in the good one and move further. Like in this case, you don't increment this one. When they don't match, you just increment the good one and then still see 3, 4 matches with this 3, 4. And then at the end you check, hey, we are at 5 in the bad one and the bad one's value is not equals to the dropped value. So by doing that, you can check, hey, sensor 2 is good one. But it's not always, you cannot assume. In this case, both sensor 1 is good and sensor 2 is good. And so it is impossible to know. And here, in this case, sensor 1 has the right values. If you see, you can do 2, 3, 2 and then 2, 3, 2, they are there. And then if you assume this is the good one, then you drop the 2 here and then there is still 3, 2 remaining, and then this matches with this 3, 2, and then 1 is 2 is replaced with 7. You don't know, I'm just talking as if you assume this is a good one. You don't know that, so that's why you do replace sensor 1 as a good one, assume sensor 1 as a good one and run through the scenario, and then assume sensor 2 is a good one and run through the scenario. Based on that, you calculate which one is a good and which one is bad. So let us look at the code. So we have run through the cases as well, and so this is what it does. Basically, you assume first initially sensor 2 is a good one and sensor 1 is a bad one, and then sensor 1 is a good one and then sensor 2 is a bad one. So if sensor 2 is a good one, then sensor 1 is defective, and sensor 1 is good, then sensor 2 is defective. If both are defective, then you return -1, and if both are not defective also, you return -1. Otherwise, if sensor 1 is defective, you return 1, otherwise you return 2. So let us look at this function can replace, which is where the lot of logic is being added. So you give the first the good one and then the bad one, and then you keep the dropped value, and you go through the index good. You run through the entire good index array. If good index equals to bad index, you just increment both of them, good and bad, and then move on to the next. If they don't match, you just assume the drop value is the good value you said, and then you just only increment the good one. So then the logic is the rest of the stuff of the bad one should match except for this element when they don't match. So let us run with this example, this code. So in this case, sensor 1 is 2, 3, 4, 5 and sensor 2 is 2, 1, 3, 4. So we are initially we check if sensor 2 is good, or we assume sensor 2 is good and then sensor 1 is bad. So for that, you run through the good array first. 2 and 2 they match, and then 1 and 3 they don't match. So you set the drop value to 1 and then move the index good to here, and then 3 and 3 matches, and then 4 and 4 matches. And so the size of bad will be 1 less. You still have to accommodate for that dropped value which we did not increment for the bad array, and then the bad index is not equals to drop value. So bad index is 5 is not equals to 1. So our assumption is correct in this case. And then you do the vice versa may not be the true. So if you assume in this case 2 3 4 5 sensor 1 is good and then sensor 1 is bad. So in this case, when you run through the good, if they don't match because you assumed B is bad, so you move 4 and then compare again, it doesn't match. 5 and then 1, compare again, it don't match, and then even this don't match. So you return false in that case. So coming back here, you say, hey, sensor 1 is defective, true, and then sensor 2 defective is false. So because of that, you return this condition doesn't satisfy and this condition doesn't satisfy, and so you return 1 from here. Sensor 1 is defective, so you return 1 from here. Let us look at the additional cases like test case 2. Everything matches, even if I assume everything matches, so only one doesn't match, so you still return true. And same case when you do the opposite. See, this is why you need to do the vice versa. If you do the opposite by assuming that sensor 2 is good, you turned out to be that assumption is correct, but assuming sensor 1 is good, that assumption is also correct, so you return -1. In the case of sensor 2, in the case of test case 3 where sensor 2 is bad, so in this case you try to run through, assume sensor 2 is good, but if you see this way, you have to drop 2 elements, whereas in this case if you do the vice versa, then you drop only 1 element, and so you say sensor 2 is defective. Comment below if you have any questions. Otherwise, I will see you in the next video. Bye.